audience will be a freshman chemical engineer that's interested in chemical weaponry and is patriotic and supports U.S. military operations. In 1995, a radical terrorist group released sarin gas through the air vents in Tokyo's busy subway system. 17 people were killed and nearly 1,000 were injured in this surprise attack. A small amount of well-placed gas was enough to overwhelm local resources and cause widespread panic. Chemical warfare is a serious issue and demands our utmost attention. The purpose of chemical weapons are to kill, injure, or incapacitate enemy troops or civilians. They also disrupt mission operations because it's very difficult to anticipate being attacked by a clear, colorless, odorless gas. They also force troops to wear full personal protective equipment, as seen in the visual, which includes a mask, an air pack, and rubber gear, which, with its added extra bulk, creates the troops to create some extra discomfort and might inhibit them from performing to their full potential. Chemical weapons are classified 3 ways: by their persistency, by their toxicity, and by the action they carry out on the body. Persistency is the amount of time a chemical remains effective after dissemination. Toxicity is how dangerous it is, and action is the action it carries out on the body. If a chemical is persistent, then it remains in the atmosphere for weeks and can contaminate ships, vehicles, and equipment. Examples of this are thickened agents, such as thickened mustard gas. A non-persistent chemical remains in the atmosphere for only a few minutes or hours, and an example of this is a gaseous agent, since it will dissipate into the atmosphere quickly. Toxicity is broken down into 3 schedules. The first one having uses in medicine, research, and for testing personal protective equipment. An example of a Schedule 1 chemical is a low-grade nerve agent, such as unthickened ricin. Schedule 2 chemicals usually have small-scale industrial uses and are commonly solvents and precursors in the production of mustard gas. Schedule 3 chemicals are large-scale industrial chemicals usually used in manufacturing, and the use of these chemicals must be reported to the Office of Protection Against Chemical Weapons. As seen in this image, when these chemicals are used in industry, a hazmat team needs to be fully prepared and ready. This hazmat technician is in a fully encapsulated Class A hazmat suit and is handling a 55-gallon drum of what is likely a Schedule 3 chemical. Examples of these chemicals are phosgene and chloropicrin. Nerve agents are a class of organic chemicals containing phosphorus. The way they work is that they degrade neurotransmitters by inhibiting acetylcholinesterase in the body. The symptoms vary with the route of exposure, but the first symptom is almost always chest tightness. Examples of nerve agents are sarin, tabin, and soman. As seen in this image, there's no blood, vomit, or other bodily fluids excreted, which makes this so deadly and scary because it's such a silent killer. This soldier probably didn't even know he inhaled a nerve agent until it was already too late. Blistering agents are kind of the opposite. These blisters look extremely painful, however, they don't normally kill. They usually incapacitate the enemy and require them to wear full personal protective equipment, which will inhibit them from performing to their full potential as discussed earlier. They blister skin and contact points, being the eyes, mucous membranes, or even the respiratory tract when inhaled. Choking agents attack lung tissue, causing pulmonary edema, or fluid in the lungs, as well as respiratory distress. They also evade detection, such as phosgene, which is colorless, simple to make, no odor, and boils at only 8.2 degrees Celsius, so it's almost always found in a gaseous form. Chemical warfare is by no means modern. Back in the early Stone Age in 5 BC, individuals were targeted when warriors dipped their arrowheads in poison to infect the enemy. It then quickly progressed to troops being targeted when major advancements were made in discovering chemical weapons in World War I, II, and the Cold War. This then turned into civilians being targeted with terrorism. This is why chemical weaponry needs to be stopped. Although there's been numerous attempts for treaties to be produced, they've never been successful because the countries that sign the treaties aren't the ones we're worried about. This needs to be stopped immediately so there are no more terrorist attacks on the United States and our allies. And there are groups in place such as the Office of Protection Against Chemical Weapons, the Chemical Weapons Convention, and the United States Marine Corps' Chemical, Biological, Radiological, Nuclear Defense. This is a group effort, however, and we need widespread knowledge and everybody to be aware of these issues so they can be stopped before they happen. These are my sources.
Thank you.